Welcome back. Today let's do some practice of plotting a complex number. I have prepared 9 questions for you. The first one, 2 plus 3i. Okay, so remember this is the real axis, this is the imaginary axis. So that 2 is here, and then 3i is here. This is 3i, this is 2. So that this point will be number 1, 2 plus 3i. And then number 2, -2 minus 5i. This is also simple. This is -2, and this is -1, -i, -2i, -3i, -4i, and this is -5i. So at this point is number 2. Okay, number 3. Squat -27 minus square root of -27. Now this is the same. So when we have two things absolutely the same and then subtracted, it is 0. So 0 plus 0i, this point. Number 3. Number 4, -7 plus 0i. Now this axis will be 0i, and we just need to find out -7 and we are done. -3, -4, -5, 6, 7. This point will be number 4. Number 5, absolute value of 7 minus i. Now remember, absolute value, let me write a note. Absolute value of a plus bi is equals to the square root of a squared plus b squared. So we first need to find out 7. 1, 2, 3, 4, 5, 6, 7. This is 7, and this is -i. So we draw a triangle. One, 2, 3, 4, 5, 6, 7. -i. So this right angle triangle, by Pythagoras theorem, we can say that this hypotenuse will be square root of this guy. It is just the hypotenuse of the triangle. So we label it. This is number 5. Number 6, absolute value of 3i multiplied by 2. Now inside the absolute value, we can do some simplification first. This is 6i, and the absolute value, we are finding absolute value of 6i. Now remember, absolute value of ai is just a. We can directly delete the I term. So the absolute value of 6i is equals to 6, which is this point. This is number 6. Number 7, -7i plus 3. Now this is just a misorder of the a plus bi form. Don't mess up the position. We can write this into 3 minus 7i first, so that the real axis will be this point, 3, and -7i. 1, 2, 3, 4, 5, 6, 7. This is -7i, and this is intersection. This is number 7. Okay, number 8. Negative 10 plus 15i over 3 plus 2i. Now if we want to simplify this, we will like the denominator with no I term. So how can we do that? We can multiply it by its conjugate. Now you see the numerator will reduce. Maybe we can use another paper to calculate this. The 3 plus 2i, negative 10 plus 15i, 3 minus 2i, 3 minus 2i. Now this is just equal to 3 squared minus 2i squared, because remember, we have a plus b, a minus b, it is just identical to a squared minus b squared. So that we can write this into this. And the numerator left with the 2 term. The denominator is just 9 minus 2 squared I squared. And the numerator is, we distribute this to this, negative 30. Negative we get positive. Positive 20i plus 45i minus 30i squared. Now remember, I squared is negative 1, so we can further simplify it into 9 minus 4 negative 1 over. Now this can be written into 65i, and then this will just be negative 13, and you see these two cancel out, and we are left with 65i over 13, and we can now simplify it. The answer is 5i. Now we just need to plot it. 5i is here, this point. So this is number 8. Okay, the last challenging question. The absolute value of negative 2 minus negative 6i over negative 2i. Inside the absolute value, we can do some simplification first. First of all, you can see that we can take out the negative sign so that it can cancel it out. The denominator negative sign become positive. These two cancel, and then we don't love it when the I is in the denominator, so that we can multiply top and bottom by I. Okay, so the denominator left with 2i squared over 2i plus 6i squared. Now what is I squared? I squared is just negative 1, so that this denominator turns out to be negative 2, and the numerator turns out to be 2i minus 6. Now we can factor out the numerator, the 2, into I minus 3 over negative 2. And these 2 cancel. We left with negative I minus 3, which is just 3 minus I. Now remember, we have to calculate the absolute value of it. So what is the absolute value of 3 minus I? It is just the hypotenuse of it, which is 3 squared minus 1 squared. So what is? We have to find out 3. 3 is here, and negative 1 is here. Negative I is here. So we draw a triangle, but it overlaps. The hypotenuse of it, I will label it with another color, and this is number 9. Now, after watching this video, you should be familiar with how to plot a graph of a complex number. Now in the next video, I will talk about some quadratic equation with the complex root. Thank you for watching.